learn how to graph with me.
Y equals mx plus b.
Yes. Which is called what?
So y equals yeah.
No, what is y equals mx plus b called?
Square root.
Slope-intercept form, right? And that's the standard form of what does that graph make? Does it make a line or does it make a curve? A line, so it's linear. So the first parent function that we learned was y equals x. Alright, what's the second thing that we graphed? That we just finished graphing, we just finished the unit on it. Quadratic. And what was the parent function of a quadratic? Y equals x squared. Good, take a point. So today we're going to graph square roots. Now the parent function, this is very, 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 very important. The parent function for a radical is y equals the square root of x. Because it's the square root function, we're going to be dealing with square roots. Does everybody understand? Let me get a picture of my notes out that I took. You'd think I would just remember them, but whatever. Okay, so when we graph the parent function, do you think we should just plug in any number to take the square root, or should we use perfect squares? Because when you take the square root, you get what? You get a... Am I teaching? I thought I was.
I'll get mine points right back.
Yeah, man. I'm trying to teach you real quick.
I didn't understand.
Do you need to lose some points?
No.
Cool. Alright, when we take the square root of a perfect square, what kind of answer do we get? Do we get a whole number or a decimal? A whole number. Well, let's start with 0. What's our next perfect square after 0? 1. And then what? 2 is not a perfect square.
4.
There is no hope for the future. Thank you, Jackson. Remember the card that we made? And how this was our next column? So it's 0, then 1, then 4, then what comes after 4?
Then 6. Then 25. Oh. Wow.
So perfect squares are what we plug into our parent function. Now, Manny is going to stop talking, or Asbury is going to freak out on him. And it's y equals the square root of x is what we're plugging it into. Now, are we going to plug these numbers in for x or for y? For x, because it's in the x column. So, what we're going to write right here is the square root of 0. And what is the square root of 0? So that is our y value. And then we're going to take the square root of 1. And what's the square root of 1? What are we going to do next? Which is, oh my gosh, it's like we know something. And the last thing, we take the square root of, which is
3.
Fantastic. Now, what do these two numbers, the one on the left and the one on the right, give us?
1.
What do they make? Coordinates. Take a point. Praise baby Jesus. They make a coordinate of x, comma, y. Which we should know how to do t-tables by now because we've been doing them for 2 years. Now, please help me plot our first coordinate. What is our first coordinate?
0, 0.
And where is that?
0, 0.
The origin. Put a dot right here. You cannot take the square root of a negative number. Please remember that. Alright, well, I tell y'all lots of things and we don't often remember it from like 4 seconds ago. Alright, what is our next coordinate?
1, 1.
Okay, so how do I get to 1, 1? He's going to do his push-ups in just a minute. Thank you. Alright, and what's my next coordinate? So how do I get to that? And next, I'm going to show you how to connect this. It is beautiful. Now, it doesn't make a straight line, does it? And it doesn't make a parabola either, does it? It makes this.
Linear.
curving.
It's curving. It's like if you cut a parabola in half and turn it on its side. Dun, 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 dun. That is our parent function. Now, when we are doing different translations, a number out front does different things. Now, remember when we had x squared and we multiplied it by a number, it stretched it if it was a whole number. And if it was a fraction, what did it do? Made it wider. If it was a negative, what did it do?
Go down.
Flipped it over. If we added to it, where did it move it?
Made it like skinnier.
I mean, it moved it up.
It moved it up. And if we added inside the parentheses, what did it do?
We shrink it. Push it to the right. We moved it to the right.
What hand is this on me?
Left hand.
Okay.
Well, you're
All right.
But you're looking at me, geniuses. Okay, now let's do this one. Alright, so now we're going to see what happens when we multiply it by a positive number out front. Now, we just said that with our quadratic, it stretched it, right? Okay, we're going to see what happens here. Now, did we change anything under the radical?
No.
So we're still going to use perfect squares. You only change what you plug in for x if you change this, but it's just x. So what are our perfect squares?
0, 1, 4, 9.
Okay,
When do we know to stop?
after 4. Yeah. 0, 1, 4, 9. Now, instead of just the square root of x this time, what is it? 3 times the square root of x. So we're going to multiply 3 times whatever we get for our square root. Does everybody understand? Okay, so it's 3 times the square root of 0. Why?
Anything times 0.
Look at you go. Take a point. Okay, next what do I do? Square root what? No, a square root 1, right? Not 3? 3 is on the outside. What's the square root of 1? What is the square root of 1? 1, and 1 times 3 is? Fantastic.
The next one's 6.
Why?
Because 10 times 3.
Where'd you get 2 from?
4 is. Yep.
Well, the next
Square root of 4 is 2.
Thank you. So we take the square root of 4 and it's 2, and 2 times 3 is 6. That's where Austin was going. Does everybody see where we got 6 from? Does anybody not see?
And next one's 9.
All right, and so then we have 3 times the square root of 9. And what's the square root of 9? And 3 times 3 is? Awesome. Now, let's plot this and see what happens. Are you guys ready? What is our first coordinate? All right, what's my next coordinate?
1, 3.
What's our next coordinate?
4, 6.
4, 6.
Yeah, 4, 6.
1, 2, 3, 4, 5, 6. And what's our next one? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. Oh, 9. Now, do I connect it with a line or does it kind of curve? Do I go below the x-axis? No. Not yet. Choo. Now, what did it do to our parent function? Look back at your parent function and see what the graph looks like compared to this one.
It stretched it up.
It stretched it up. It made it go wider, so it's still doing the same thing, right? Do we need to graph our parent function on here to make sure you see it, or are you guys good? Okay. All right. Now, what do you think the next one is going to do? The next tabby says y equals how? How do you mean? Y'all take a point. All right. So our function this time is y equals negative 2 times the square root of x. Now, do we still need to use our perfect squares?
Yep.
Why?
Yeah, because the square.
Because we gotta have the square root.
And we didn't change anything under here, did we?
No.
Fantastic. All right, 0, 1, 4, 9. All right, and now we're plugging in, and it's negative 2 times the square root of x. Negative 2 times the square root of x. So can you guys do that without me?
Yes.
Okay, try it without me. And then we'll check it together. All right, what'd you get for your first y value?
0.
Okay, what'd you get for your next y value?
Negative
Good. And then?
2. 4.
And then? How many of us got that right? Good job. Take a point. Now, where did we get negative 4 from?
You square root of 2 and then you multiply it and you get negative 4.
Okay, so for those of us that can't hear two people talking at once, you take the square root of 4 and both of you get a point, and you get 2, and then 2 times negative 2 is negative 4. What about the square root, what about negative 6?
You square root 9 and then you multiply it by 3 to get negative 6.
You multiply it by 2.
Well, you know
Negative
what
2.
I mean.
Alright, so what's my first coordinate, Troy, that I need to plot?
0, 0. 4. Why should you get the push up here? That's it.
I know that he's going to have to do them. And also, please stop chewing your gum like that. You look like a cow chewing cud. I'm serious. Alright, our next one is, ooh, okay. We're about to leave each other, aren't we? Alright, homework. You have 3 problems. Y equals 4 times the square root of x. 2 problems. And y equals negative 5 times the square root of x. Graph both of those. Graph those.
Negative 4.